Welcome to my channel where you learn the topics related to structural analysis and design in a simplified manner. Shear force and bending moment. These are very important terms in the field of civil engineering, mechanical engineering and allied branches because these are the two important internal forces on the basis of which we design various structural elements such as beams, slabs, footings, staircase, etc. These terms are also important in design of machine elements in mechanical engineering, and therefore it is important to learn this topic from competitive examination or interview point of view. In this video, I am going to share with you some simple techniques to draw the shear force diagram of cantilever beam. Whatever techniques I am going to share with you is equally applicable to all types of beams. So here we are going to discuss only cantilever beam. Based on support conditions, we can classify the beams as cantilever beam, simply supported beam, then continuous beam, fixed beam, etc. Now you know that cantilever beam means one end is fixed and other is free. So to understand the cantilever beam, first of all, you have to understand what is meant by fixed support and what are the reactions at the fixed support. Now because of the support, when end of the beam cannot move in vertical direction or horizontal direction, or if it cannot rotate, then that support is called as fixed support. So in case of fixed support, since it cannot move in vertical direction, vertical reaction will be developed. It cannot move in horizontal direction, so horizontal reaction will be developed. It cannot rotate, and therefore rotational reaction will be developed. So fixed support, at the fixed support, the end is restrained against horizontal movement, vertical movement as well as rotations. And therefore there are three reactions at the fixed support. Now here we are going to draw only shear force diagram. So in shear force diagram, we are interested only in vertical forces. So therefore, while solving the problem, in this video, we will calculate only vertical reaction. Though there is reactive moment present in all the beams, we will not calculate because it is not required to draw the shear force diagram. So let us see what is meant by cantilever beam. Now cantilever beam, as I told you, it is a beam which is fixed at one end and free at other end. It looks something like this. So this fixed support is also called as built-in support, clamped support or restraint support. So one end is fixed and other is free, then that beam is called as cantilever beam. So fixed support can be on the left side or it can be on the right side. So because of fixity, this end cannot move in horizontal direction, in vertical direction, and it cannot rotate, and therefore three reactions are developed at the fixed end of cantilever beam. Now what is meant by shear force? Actually I am not going to explain you in detail the concepts of shear force and bending moment, etc. Here in this video we are going to study only simple technique how to draw the shear force diagram. So for that, first we will understand what is shear force. What is the definition of shear force? What is meant by shear force diagram? And what are the sign conventions for shear force? So shear force at any section of a beam is given by algebraic sum of all the vertical forces on the beam acting on the left or right of the section. That means whenever we want to calculate the shear force at any section, you can just add the vertical forces either from the left side or from the right side of that section. Now what is shear force diagram? Shear force diagram, the diagram which shows the variation of shear force along the length of the beam is called as shear force diagram. Now we will see what are the sign conventions for shear. Now you should remember one thing, that it is always in pair. Shear force is always in pair. So it is pair of forces causing shearing of beam. So what is meant by positive shear force? If there is a section and if you are if you are adding the forces from left side of the section, then if you get upward force, then it is called as positive shear force. But if you are calculating the forces, if you are adding the forces from right side and net force is downward, then it is called as positive shear force. Now what is negative shear force? If this is a section and if you are calculating from left side and net force is downward, or if you are calculating from right side and net force is upward, then it is called as negative shear force. And unit of shear force, you know that it is a force. So unit of shear force is kilonewton or Newton. Now we will see how to draw the shear force diagram. Now I am going to share with you some simple steps that you have to follow while drawing the shear force diagram. So remember these steps while drawing shear force diagram of any beam. It may be a cantilever or simply supported or continuous, any beam. So what are the steps you have to follow? The first step is calculate vertical reaction at fixed support. So just add the forces upward positive and downward negative. Calculate vertical reaction at the fixed support. Then second step is always start drawing shear force diagram from left end, because upward is positive and downward is negative. If you take from right side, then it will be opposite and you will get confused from that. So it is always better to start drawing the shear force diagram from left end. We will see while solving the problem this. Then move your hand in the direction of force. So what you have to do to draw the shear force diagram? First calculate vertical reaction at fixed support just by adding the forces, vertical forces. Then start drawing the shear force diagram from left end and then move your hand in the direction of force. Then whatever shape you get, that will be the shear force diagram. So let us understand from some examples. In cantilever beam, there are two cases. Sometimes right end is fixed, sometimes left end is fixed. So don't get confused with this. So let us see first example, very simple example. When left end is free, means this is free and this is fixed. What is first step? Calculate vertical reaction. So if this is W, this will be upward W. Then after calculating reaction, what is the second step? I told you that you have to start from the left end. So always start from the left end and move your hand in the direction of force. What does it mean? Now this is the line from where we are going to start our diagram. So starting from left end, move the hand in the direction of force. So W is downward. So we will move like this. Then there is no force. So no change up to this. Then again upward force. So move your hand in the direction of force. So the diagram will be like this: W downward, no change, and W upward. So this is the way to draw the shear force diagram. Now suppose left end is fixed and right is free. It is like this and it is subjected to W. So what is first step? First step is to calculate the reaction. So W is the reaction. Then you have to always start from the left side and move your hand in the direction of force. So you have to move your hand in the direction of force like this, W, then no change, and then again W. So shear force diagram must close. So if you draw for this case, W upward, no change, and downward. So there will be change in the sign of shear force diagram depending on where is the fixed support or where is the free support. free end. So these three steps we have to follow. First is calculate reaction. Second is always start from left end and then move your hand in the direction of force. So let us solve some more examples. Now suppose the beam is like this, left end free and right is fixed and subjected to uniformly distributed load. You know that total load due to uniformly distributed load is intensity of the load multiplied by the distance. So total load due to this is W into L, and therefore first step is to calculate the reaction. So what is reaction? So suppose reaction is upward, RB minus W into L is equal to 0. So you will get RB is equal to W into L. Then second thing you have to remember that you have to start from the left end. So we start from the left end. Since it is uniformly distributed load, we will take our hand uniformly downward like this. Okay. Or if you write the equation, what it is W into X, because total load due to this is W into X. X has power 1 means it is a linear variation. So what you have to do in case of UDL, you have to take your hand uniformly downward like this. So what is total force up to this? W into L. So we will draw the line like this up to WL, and then we will take our hand in the direction of this reaction WL. So the diagram will look like this, WL, and take it upward, WL. Now suppose the left support is fixed and right is free. Again calculate first reaction. It will be W into L. So we have to start with left end. Take your hand in the direction of force, which is WL, and then uniformly you have to take downward. And here at the end, shear force will be 0. Remember that if there is point load, then only there will be ordinate at the free end. Otherwise, at the free end, shear force is 0. So diagram will look like this. First, you take your hand in the direction of force, means in the direction of reaction. Then uniformly we will move downward, and at the end, the shear force is 0. So this is the shear force diagram when the beam is subjected to uniformly distributed load. So if the end is towards right, fixed end is at right, then it is negative, and fixed end is on the left side, then it is positive. Now let us take next. Now this example is many times asked in the interviews, that a cantilever beam subjected to some moment. Now remember that if there is rotational force, there will not be any shear force diagram for this beam. Shear force is summation of vertical forces, not moment. And therefore, due to moment, there will not be any shear force. So no shear force diagram will be there for this case. If there is moment, there will not be any effect on the shear force diagram. So for both the cases, there will not be any shear force diagram. So remember this. Now we will solve one simple example with number of forces. Let us consider this beam, which is fixed at left end and free at right end, and this is subjected to this type of loads. So as I told you that first step is always calculate vertical reaction just by adding these forces. So we will calculate this reaction. We know that RA upward positive, RA minus 3 due to this 1 kilonewton per meter, 1 into 2, and minus 2.5 is equal to 0. So from this you can get RA is equal to 7.5. Now how to draw the diagram? Now to draw the diagram, you have to move your hand in the direction of the force. So first force is 7.5 kilonewton. So you have to move your hand up to 7.5. Then there is no change up to B. So it will be a horizontal line. Then it will be downward force 3 kilonewton. So move your hand by 3 units downward. Then there is no change again. Then uniformly downward. Then again no change, and then 2.5. So let us see how it look like. So first you have to move your hand in the direction of RA. So we will move upward. Then there is no change up to B. So no change. Then we will move downward by 3 units. So this is 7.5 minus 3 means 4.5. Again no change. Then uniformly downward by how much unit? 1 into 2. So 4.5 minus 2 means 2.5. Again no change, and then downward 2.5. If the diagram is above the line, then it is positive. If it is below the line, then it is negative. Now same beam we will solve by considering right support as fixed and left as free. So first step is to calculate this reaction. So take summation of vertical forces equal to 0. So this is upward. So RE minus 2.5 minus 1 into 2 minus 3 is equal to 0. So you get RE is equal to 7.5. Then I told you that you always start with left end. So here start from left side and move your hand in the direction of force. So here 2.5 downward, then no change, then again uniformly downward, then no change, then downward by 3 units, then no change, and then move upward. So let us see how it look like. So first move your hand in the direction of 2.5 downward. Then there is no change, no force. So horizontal line. Then move your hand uniformly downward by how much unit? 2 into 1. So 2.5 plus 2 is 4.5. So it is 4.5. Then there is no change. So horizontal line. Then move downward by 3 units. So 4.5 plus 3 means 7.5. Then again there is no change in the force. So horizontal line, and there is vertical reaction of 7.5. So this is below the line, therefore it is negative. This is positive. Okay. So this is how we can draw the shear force diagram for any type of beam. Just move your hand in the direction of force. But remember that you have to start with left support or left end. First calculate reaction and start from left end. Move your hand in the direction of force. You will get right shear force diagram. Now in this example, we have studied point load and uniformly distributed load. Now in next example, we will take also a rotational force. So let us consider this beam, cantilever beam, which is fixed at A and free at B, and these types of loads are there. So first step is always to calculate the reaction. So there is vertical reaction. So taking upward positive and downward negative, this is RA minus 20 plus 40. There is no effect of moment in addition of forces. Then minus 40. So we will get RA is equal to 20. Now how we can draw this sketch? So this RA is 20. So you have to move your hand in the direction of force. So here we will take by 20 upward, no change, by 20 downward. So it will come to this point again, then no change, then 40 upward. Then there will not be any effect due to rotational force. So no change, and then 40 downward. So it will look like this. So how we are going to draw this? First we will take upward 20, no change, downward 20, then no change, then upward 40, and there will not be any effect due to movement, and then downward 40. So this is how to draw the shear force diagram. Now next we will discuss the beam with partial UDL. We will discuss two cases. when the UDL is near the free end and when the UDL is near the fixed end. Now let us see what is the change in the diagram. So first step is always to calculate the reaction. So RA minus what is total load due to UDL? It is 10 into 3 is equal to 0. So what is RA? RA is 30 kilonewton. So how will be the diagram? Diagram is 30 upward, then there is no change, then uniformly downward. And at free end, always shear force is 0. Unless there is point load acting at the free end, shear force at free end is 0. So here we have to take your hand upward by 30 units, then no change, and uniformly downward 10 into 3, 30. So it will come to 0. So this is shear force diagram for this case. Now let us see how it look like for this case. So RA minus 10 into 3 is equal to 0. You will get same reaction. RA is equal to 30 kilonewton. Now how we are going to draw this? We will take 30 upward, then uniformly downward. So 30 minus 30 is 0. It will come to this point. And after this, there is no force. So there will not be any shear force diagram for portion BC. So this is how the shear force diagram will look like for partial UDL. Now so far we have discussed the effect of point load, uniformly distributed load, partial uniformly distributed load, and moment on the shear force diagram. Now we will see triangular load. Let us consider this beam, which is subjected to triangular load with apex here and base here. We will discuss two cases. In first case, this point, 0 point is near the fixed end. In second case, 0 point is near the free end. So let us see what is the change in the shape of the diagram in these two cases. So first step is always to calculate the reaction. So RA minus what is the total load due to this triangular load? It is equal to the area of the triangle. So it is half into base into height. So you will get RA is equal to 120 kilonewton. Now let us see how will be the shape here. Take your hand 120 kilonewton upward. So this curve will be parabolic and this curve is positive. By mistake there is positive negative sign, but this is a positive diagram because it is above the line. Okay, so this curve will look like this. Now let us see how the curve look for this second case. Now let us discuss the second case. In this case also, first we will calculate the reaction. RA minus area of this triangle, half base into height, is the total load due to this triangle, and we get RA is equal to 4000 Newton. Okay, this is how to calculate the reaction. Now how the shape will look like? You have to take 4000 upward. Now just observe the curve. In this case, when the 0 point is here, the curve is like this. Whereas if the 0 ordinate is at free end, the curve is like this. Because here there is variation which is very less due to this curve. But here there is sudden change in the diagram, sudden change in the ordinate because here there is more ordinate as compared to this. And therefore this shape is like this, whereas this shape is like this, and this is second degree parabola. If you write the general equation of shear force anywhere, you will get second degree curve. So this is the change, or this is the comparison of these two types of triangular load. Now once you know that this diagram is positive, then you can calculate ordinate anywhere you want by taking the area of triangle up to that point. For example, if you want to calculate what is the shear force at this location, then just take the area of this triangle and calculate what is the shear force there. Okay, so this is how we draw the shear force diagram for various cases. So from this discussion, what we can conclude is when there is a point load, we get ordinate at free end only when there is point load acting at the free end. So here there is point load, so we get the ordinate. If there is only point load, then we get only straight line, and this is a 0-degree curve. Then if there is a uniformly distributed load, then the degree of curve is 1 because x has power 1 w into x, and therefore there is linear variation like this. And one thing also you can observe here, that if the fixed end is at right, you get, and the load is downward, fixed end is at right, then you get negative diagram. And if the fixed end is at left, then you get positive diagram. Then we have seen that if there is rotational force, there is no effect on shear force diagram. In this case, we have seen that due to uniformly distributed load, there is first degree curve, that is a linear variation, and if there is point load, it is a 0-degree curve. If left end is fixed, then it is positive diagram. If right end is fixed, then it is a negative diagram. Then from this diagram, from this case, we have studied that there is no effect of rotational force on the shear force diagram. Then we have compared two cases of triangular load, when apex is near the fixed support and when apex is near the free end. So you can observe the variation of the shear force. It is 2nd-degree curve when it is a triangular load. So stay connected to watch more videos on strength of materials, analysis, and design of structures. I hope you will find this video useful. Thank you for watching this video.